Welcome to the Unstructured Data Podcast Meet the Makers series, where we discuss today's most exciting technical developments in generative AI with the people who are building them. This podcast is hosted by the team at Zilliz, the company behind the open source vector database Milvus. We're passionate about working with unstructured data and love chatting with others doing the same. Be sure to check out our AI Trailblazers episodes for more conversations with AI leaders. Enjoy the show.
Welcome to Meet the Makers. I'm your host, Stefan. I'm a developer advocate here at Zilliz. And today I'm joined by a colleague of mine who actually carries the same first name, Stefan. So in this episode of Meet the Makers, we're going to chat about LLM-as-a-Judge and the importance of regularization in general and answer its importance as well. So welcome, Stefan. Thank you for joining.
Yeah, thanks so much. Also, Stefan, pleasure to be here and excited to chat.
Yes. So first question. What's your favorite animal?
Ooh, great question. I would have to say cats. We're absolutely like a cat-obsessed household. We have two cats. We sort of, really like spoil them rotten. They're just so funny as well. Just like unintentionally hilarious.
Yeah. So like definitely a cat family then, like no doubt here. Okay, so like on your clothes, you can see you have like cats as well.
Oh, well, yeah. that's the downside. You sort of look a bit sort of shabby with all, picking up on the cat hair.
Okay. And yeah, maybe can you tell us a bit about like, how did you get, where you are now and what was your journey?
Yeah, sure. Well, first I took a bus and then you mean like in life? Okay. I got into machine learning via a bit of a circuitous route, and that was via econometrics and statistics. So during my undergrad, I was really passionate about economics as well as statistics and math. And statistics is very, very closely related to machine learning. So, there's often, I think even more so these days than back in like 2009 to 2012 when I was doing my undergrad. And so I saw sort of like this surge in interest in machine learning. I really got into it. I took up the Chris Bishop machine learning textbook and devoured that, and also took an interest in probabilistic graphical models, which are really connected to statistics and probability as well. And I just, when I was sort of making a choice, like, do I want to become an economist? Do I want to become a statistician? What about machine learning? I sort of thought it seems like AI is the future. Deep learning was just starting to explode in interest as well around 2013, 2014, when I was studying grad school. So I think it was a pretty easy choice what to like study at grad school and sort of like which direction to point myself in. And no regrets. I absolutely love machine learning. I'm fortunate now that, so I was doing like generative AI related stuff at the time, although we would have called it deep generative models, deep Bayesian learning, etc. So now that like what I was learning then, which was perhaps considered kind of like not very useful, has sort of exploded into like the main topic. That's very exciting.
Now.
Yeah.
It's their thing now. I was like, everyone is like, okay, are you working on GenAI? If you're not, what are you doing? Okay.
You're just wasting your life.
Exactly. So you've been doing that for a while then, right? And so have you seen like the evolution as well of, what used to not be called GenAI into GenAI now? And maybe like to start is like, you've been, I guess, seeing like a lot of RAG systems for the past, year and a half, everyone has been bombarding everyone with like, you should use RAG. If you don't,
including us.
Yes, including us. And so why do you think it's like important to then evaluate RAG systems? Like it's one thing to build them, but then, how do you make sure they're actually good quality, and why is it important to check?
Yeah. So, I think it's important because a RAG system in production is just like any other ML system in production. Perhaps like the really dominant topic when I was in industry before joining Zilliz was recommender systems being at two social media companies. And, recommender systems have so many different options to like build them, design them. There's sort of these sort of issues about how they interact with users and the feedback loop there. And they're also like critical to like the revenue of the company as well. So the recommender system sort of really determining how much attention or time you can grab from a user. In the same way that it's really important to evaluate these like older ML applications and systems. Similarly, it's really important to evaluate RAG pipelines because there's just so many different design choices, like a infinitude, if that's a word, of ways that you can build them and the methods. Those choices could have really big revenue implications for companies.
Yeah.
So, it's not like a new idea. So we do A/B testing for recommender systems, for website design, user experience, etc. So we should also just make it part of our standard practice to do this sort of like testing and evaluation for RAG systems.
Yeah, fair. And it's like, I mean, you mentioned, like sometimes it can be costly as well. There's still this famous example now in the RAG world where it's like, this Canadian airline company, I think, had to pay a lot because the chatbot said, yeah, you can actually, get this amount of money. And then, they got sued because they didn't pay. And then actually the judge was like, yeah, but your system said so.
You make a really interesting point there. So I guess there's sort of different aspects of cost. There's sort of like, cost and revenue. So on the revenue side, you want to be like maximizing your user engagement through like this sort of more incremental optimization. Yeah. But on the flip side, you want to avoid these catastrophic risk of maybe the example you gave, making a claim that you could then be sued by. You don't want to be like outputting copyrighted materials or defaming someone, that sort of thing. So evaluation, it's both on the revenue side, but also minimizing the risk and potential cost as well.
Yeah, definitely. And one of them that I've heard a lot about in the past is like LLM-as-a-Judge. So there was a paper that was released, tell me if I'm wrong, but like a couple of months ago or like 6 months ago or something. For the people that don't know what LLM-as-a-Judge is, can you maybe give us a quick intro and what it is and what it consists of?
Yeah, so things are moving so quickly in generative AI, it sort of seems like a new idea was just released yesterday. So this one was actually published, I believe, in early 2023.
Wow, so years ago now.
So it's a classical method, and so the premise of this paper is that we can use LLMs as judge models to evaluate the output of other LLMs, and that actually is a reliable method, given some caveats. So I think, so the sort of the value of the paper was this sort of like evidence, empirical results that this actually works and is sort of reliable.
Okay. I've shown this example a bit in some of my talks, for example, and then a lot of people come to me and they basically all ask the same question is like, okay, how can you trust an LLM to like evaluate another, when like the first one may have made a mistake, how can you make sure that the second LLM or like, like what it's evaluating, your RAG system is actually going to be fair? And also, sometimes also I think it's been shown that, some LLMs might have a preference for themselves, if they evaluate themselves as well in something. Yeah. How do you address those?
Yeah, sure. So that's a great question. And I think it sort of goes back to this, it seems like a sort of like a circuitous type argument or reasoning. But I think to answer the question, there's a couple of ways. And the first most obvious one is use a really strong LLM as the judge. So maybe you're developing a system, you're sort of using like much smaller, probably like fine-tuned LLMs in production for a few reasons. Like I think a big one could be just to like reduce the cost of inference for your system. But you can still use GPT, ChatGPT, Claude, etc., like these really large 400 plus billion parameter models as the judge. And those will be a much closer approximation to the gold standard, which is human evaluation. So that's the first thing. So you can just use a very strong model. Secondly, we can actually have models that are specifically fine-tuned for judging. Oh. And so they've been fine-tuned in a way that they avoid some of the almost like cognitive biases that like a non-specialized judge model might have, and then also potentially be specialized for a specific type of judging. And so that's like a way that you can have like an effective judge model without having to pay the cost of like a really strong 400 billion parameter.
Oh, interesting. And do you know like any open source one, or do you think, or they're mostly like closed source with those ones, the judging ones?
Yeah, so we're starting to see open source ones get released, I think in the past 6 months or so. So, for example, Meta has some versions of Llama which are trained to sort of be judges for various guardrail type tasks like toxicity. And I would say just like go on Hugging Face, do a model search, and you will come up with at least like half a dozen that pop out really easily.
And so you would say very important to use like a stronger model in the first place, maybe like even if you're using, I don't know, Llama 3.3 now, like a small one, maybe as a judge, you still want to use like a big one, right?
So, yeah, I mean, I think it's sort of like a empirical question. If you do fine tune, can you like get away in a sense with having a much smaller model? Okay. And I think that sort of like seems to be true for like sort of non-judging tasks. We can fine tune, you know, with like LoRa, etc., much smaller models to perform very specific tasks. Like maybe you're doing some sort of like classification or you know, some sort of like specific reasoning. And so those very specifically fine-tuned small models done in the right way can have GPT-4 performance. Okay. So in the same way, it seems sort of reasonable to believe that much smaller judge models, given that they've been fine-tuned for a specific task, can have similar or even exceed like the performance of like a really strong LLM.
Okay, cool. So obviously the world is like, not everything is beautiful in the world, you know, not everything works out of the blue. So you still have some biases.
Oh, sorry. I was going to say, not everything is beautiful in the world. Well, you should come to San Francisco. I think there's a lot of beauty there. But yeah, you're right. So these judge models, there are some challenges, limitations, and it was observed in the original research paper that they can exhibit some very undesirable, similar to sort of like cognitive biases that humans might have. Okay. And so, for example, one is that a judge model might give a different decision on whether it prefers model A or model B's response. Or maybe, So it might
really in the format of the answer, basically, it's really like
exactly. So
preference.
If in some cases, if you change the order of which model is presented first, then that changes the answer of the judge. And obviously like that's something that we don't want. It shouldn't matter what order the information is presented.
So this is what it's called position bias, right?
Correct. Yeah.
And there are also like other biases. So there's like, you know, verbosity bias, I guess, like how verbose it is as well. And there is like, you know, something like can answer but cannot judge, you know, like how do you address those different pitfalls then and biases?
Yeah, sure. So and just for listeners, so verbosity bias, it's been observed that an LLM judge can prefer an answer that is essentially take a simpler answer and then just like make it a bit more verbose, but it still answers the question. So obviously we don't want it to just prefer answers because they're longer. It should be about, I mean, I think if anything, the opposite. If the answer is correct, then I think we should have a preference for brevity. So how do we fix this? Well, I think I think there's like a naive way, which is for example, for position bias, just try both orderings, see what the judge does, and then if the judge doesn't agree in those two scenarios, you know, maybe defer to another model. Alternatively, we can actually fine-tune judge models to avoid these biases. So we would construct a data set, maybe do some sort of, say, DPO or some other preference optimization. And
DPO maybe for the people that are not familiar.
Yeah, sure. So that stands for direct preference optimization. And it's a step in the training of a large language model where we give it an input and then we give it two or more outputs, but we say, we want you to prefer one of them. And so that's how we take like an LLM that just outputs words into a chatbot that can respond to and you can have a conversation with. But, you know, it doesn't have to be just for chat. There's any sort of task where it's easy to construct data where you say, here's the input, I prefer this one over this one in terms of the output. Yeah, you can do this preference optimization.
Okay. Okay, cool. And so then you've been mentioning like, okay, maybe you can create your data set and something, but is there like maybe like some tools, that can be useful actually to build those, because you don't want to do it yourself. It might be very time consuming. Also, I'm technically not an expert in that, so some people who might be more familiar with that. So do you have like any that like how can you build something like that?
Yeah, sure. And firstly, I just wanted to point out, maybe it's like relevant to the listeners, like I think things are moving so quickly in generative AI. No one is an expert. And the topics, I mean, you could just sort of delve into a topic and, each topic like transformer architectures, LLM evaluation, they're all sort of very broad within themselves. So yeah, I guess like we just have to sort of like pick up what we need to build the task at hand. So you make a good point, which is that if we were to do this manually, implement LLM-as-a-Judge, so we would have to firstly, work out the right prompt for the type of evaluation. So for example, suppose we want to judge what is the faithfulness of the LLM's output, given the context that it had, and give that a score from like 1 to 10.
Yeah.
Then, we'd have to think of the right prompt. Then you'd have to put together like a little pipeline to sort of call the model that you're judging, put that into the judge model, call the judge model. And then for many metrics, there's it's not just like a standard, take the output and return that. There might be like a formula you have to apply at the end.
Okay.
And so it makes sense to use a library specifically for this purpose. And, now there's several, and that means that you can just focus on what metrics should I evaluate, what data should I use to evaluate those metrics on? And then how do I use that to guide my RAG or agent pipeline decisions?
Okay, I've heard a lot, for example, about RAGAS. So is it something that you would use for that, or like how would you use it, or maybe something else as well? Like
yeah, sure. So I think we're in this early stage where there's a lot of competing tools and technologies to do the same thing. It's maybe sort of unclear like which one is going to have sort of be the winner, if you will. Yeah. So I mean, if you remember, like before TensorFlow, there was Theano and Karif and MXNet, and I think about those. Yeah, so seems like a long time ago now.
Yeah,
I think we're in a similar stage with this sort of tooling. So there's several libraries to do this evaluation. So for example, RAGAS is one you mentioned. Another one might be, Hugging Face, they have one called Light Eval, for example. But so as far as I can tell, RAGAS, it has like a good balance of feature completeness, ease of use, good documentation, and size of the community using it.
Okay.
So it's what I'd recommend to do evaluations.
To start with, actually, or like, maybe you might find something else later on, but it can be useful to start with that. Okay, cool. And let's say you are working for a company and you're going to start, something like that. And
I do work for a company.
Yeah, let's say when you work one, you're going to build your rack system, and then you're going to build something end to end, and then it's always the case. It's like you want to build your ML model as fast as possible, then you want to put it in production as fast as possible as well. But back in my days, I worked a lot with data scientists, and I was always saying a model is not in production if it's not monitored. So how do you balance speed and quality when you're going to launch like a rack system, because you also have to have like the evaluation, and how do you balance those out?
Yeah, sure. So I mean, I think the answer is get something out there. Don't do all the evaluation just for your prototype. Maybe do some evaluation and make sure like the chance of like a catastrophic legal risk coming out of your product is that risk is minimized. But in terms of like this sort of like fine tuning, adding more steps to the pipeline of your RAG system, whether that's like prompt rewriting, different types of prompt re-ranking, maybe some sort of steps of like reflection or whatever. So before you do that, get your baseline prototype out there. And then, so the second thing I would say is at my previous roles, I've worked quite a bit with the tooling, both like the users and the maintainers of the online testing, or like the A/B testing tooling. And so I think one of the lessons I sort of learned from that, seeing how engineers do experiments, is if you don't do it, and this is not to disparage engineers, but if you don't do the experimentation in the right way, then it's essentially pointless. Yeah. And so I think what that means is that there's sort of several things, like choose your metrics in advance. Don't obviously cherry pick your metrics after the experiment. Prefer a smaller number of metrics. Don't have 500 metrics. You need to have a clear decision criterion from that. Mm-hmm. Also, if you're doing statistical testing on top of these metrics, so when we calculate these quantities, it's not just just a number. It's in essence we're making a point estimate of a random variable, which is so it's the metric that you're measuring is a random variable. Mm-hmm. And so you may want to also think about some uncertainty in that metric. Also, because these metrics are very expensive to evaluate, often and at scale. So therefore, it may be preferable to use less data points, calculate some measures of your uncertainty, and then do some statistical hypothesis testing on that, just in the same way that we do for when we're building recommender systems online or regression, etc., any other sort of ML system online. So, geez, I think I'm going a bit off track here. But so in answer to the question, start with a baseline, just get the baseline out there, then think about this sort of much harder process of continued principal experimentation to iterate on your base design. And one last thing I'll just throw out there is I think you should definitely use Bayesian hypothesis testing.
Oh, that's a hot take here. No, but it's a good point. It's back then, or a long time ago now when I started. So I came from research, and I was always never really comparing to a baseline, because the baseline was the previous papers. And when you enter the industry, it's something that is actually very interesting. It's okay, maybe you're going to build a model, and this model is technically not very good, but it's better than the baseline you have. And that's something that data scientists and I guess people or AI engineers or whatever you want to call them now, it's something that is very important, I feel to have a baseline. And then as long as you improve on this baseline, it's already an achievement, I feel and then you can go a bit more later on if you want to.
Totally. And I think there's obviously a very big difference between 0 to 1 and a million to a million plus one. So
exactly,
I think it's most likely that many companies are putting their first RAG system into production. So that's going from 0 to 1. I recommend a system at TikTok, Meta, etc. That's had so much work, experimentation done on it. The baseline is already a billion. Yeah. So it's much harder at that stage to actually sort of work out what actually is an improvement. Yeah, so I think it's sort of a consideration. It sort of becomes more relevant down the line as it becomes harder and harder to make improvements.
Yeah, definitely. And okay, cool. But maybe moving on from this subject quickly. So,
if we have to, it's
yeah, I can feel you're that's your thing. But 2025 is the year of agentic. That's the word of the year. Actually, I'm defining it like that. Yeah. But that also means more and more people are also going multimodal. So it's we started with the RAG system with only text, but now, everything that is released, if you're not multimodal, you're a bit lame. So how do you, if we add images, maybe audio, maybe video, do you have an idea of how to then evaluate a RAG system that would then maybe, contain those?
Yeah, that's a good point. So I think it's sort of in these packages, I think it's sort of assumes that you're most likely to be evaluating a text in, text out type system. So I mean, the same general principles apply. If you're working with multimodal inputs and or outputs, then you just need a multimodal judge.
Okay.
And so, all of these closed source, really large ones.
Gemini, whatever.
Exactly. So, they're already multimodal. So I think in many situations, you probably wouldn't even have to change much in your code to work in that scenario. And then I think in terms of open source multimodal judge models, I don't know if those currently exist, but if they don't, they will shortly because they'll be needed.
Okay, no, that's interesting. Yeah, I mean, it's kind of makes sense, use the same modality that you have as input as the output and the judge. Okay, yeah, I actually had no idea about that, so I'm very happy that I asked this question. Okay, maybe we're gonna go more into closing this podcast. So, like we talked about like a lot of different things.
Let's do it.
What do you think? Maybe something that in the GenAI community, like we should really need to talk about more honestly. Is there like one thing?
Yeah, that's a great question. And I'm just thinking, I don't want to say anything too controversial or upset any startup founders. So I would say, I mean,
you can, like back then, Kubeflow people didn't like me because I said on stage that I didn't like Kubeflow.
So I think the obvious answer, so I'm going to sort of stay clear of that, but the obvious answer would be we sort of really need to distinguish between hype and substance and be like realistic in terms of what we can achieve with our applications and like the rate of adoption, and even like, realistic about like, is this intelligence? What is the feasibility of AGI? So I think that probably excludes me from getting hired at many.
You don't believe in the 500 billion plan? Maybe.
Well, it depends. Like, obviously like more investment in infrastructure to store data, train these models, serve these models, enable researchers to do experimentation faster. That's a really good thing. Okay. But geez, I said I wasn't going to get into this topic, but now you've you sucked me in. But so steering clear of the like hype versus substance, I would say something is, let's not forget about everything that happened before in the world of ML research before ChatGPT exploded and Stable Diffusion and so on in 2022. Okay. So, let's just not like totally sort of discount the value of ideas from other fields of machine learning and AI. Many researchers feel strongly that we necessarily like need ideas that are probably not going to come from like inside this sort of like, let's just build a foundation model and do like, even with steps of like feedback and tool use and so on. I have a strong feeling that we're going to need ideas from Bayesian modeling or probabilistic modeling, as well as statistical inference, and presumably some other fields as well. So maybe if someone wants to like, not follow the herd, do something a bit different, I would say think about like how everything that happened before ChatGPT can sort of like complement these models and systems.
Okay. Oh, cool. Yeah, that's a nice one. I guess we're getting close to the end now. One last question then. What would you like people to remember or take away from this conversation?
Yeah, great one. So a few key takeaways. So the biggest one is to produce a machine learning model, you have to do principled experimentation, which requires principled evaluation. And so evaluation is just super important. Don't leave it out. By all means, get from your 0 to 1, get your prototype out there. But then it's really important to think about, how can I evaluate and improve my model in a principled way? Okay.
So yeah, don't forget the baseline, basically, people. Well, thank you very much, Stefan, for this episode. Thank you, everyone that has listened to it. I was Stefan, I was your host, and I hope to see you soon. Don't forget, you can also join us on our socials. You can find us on LinkedIn or on Discord as well. I'll let you check out directly our website, so zilis.com or milvis.io. You'll find all the information that I needed there. Thank you very much, and I hope to see you soon. Bye.
Yeah, thanks so much, Stefan. Okay, take care.
Thank you for joining us for today's episode of the Unstructured Data Podcast. To learn more about Zilliz and start making sense of your unstructured data, grab a free account at zilliz.com/cloud. That's ZILLIZ.com. We'll see you next time.